Astronomers have just made an extraordinary discovery using the James Webb Space Telescope, JWST. For the first time, they've identified the most distant globular clusters ever observed. These ancient star clusters, composed of millions of stars, could be the elusive remnants of the very first stars that formed after the birth of the universe. So, what exactly did the James Webb Space Telescope uncover, and how could this reshape our understanding of the cosmos? Stick around, because we're diving deep into this fascinating breakthrough made possible by the most advanced space observatory ever built. If you're passionate about space exploration, the mysteries of the universe, and cutting-edge scientific discoveries, make sure to subscribe to our channel. Don't forget to like this video and turn on the notification bell so you never miss the latest cosmic updates. The first science-quality images captured by NASA's James Webb Space Telescope have astounded the world, offering a glimpse of a distant galaxy surrounded by dense star clusters. These clusters, possibly containing some of the earliest stars in existence, are located a staggering 9 billion light-years away from Earth. A team of Canadian astronomers homed in on a galaxy nicknamed the Sparkler due to its unusual, stretched appearance and the reddish-yellow blobs, compact objects, that seem to orbit around it like celestial embers. These surrounding objects, which resemble cosmic fireworks, might be the most distant globular clusters ever identified. But what makes this so significant? To understand, we need to first grasp what globular clusters are. These are tightly bound groups of ancient stars, some of which are among the oldest in the universe. They've been present since the early formation of their host galaxies, acting as living fossils of cosmic history. By studying them, scientists can peer into the formative years of galaxies and unravel the processes that shaped the early universe. In the case of the Sparkler galaxy, astronomers discovered that 5 of the surrounding compact objects are, in fact, globular clusters. These could be the oldest ever detected, perhaps existing since the universe was just a fraction of its current age. Dr. Kartik G. Iyer, co-lead author of the study, expressed his excitement about the discovery, stating that it was astonishing to find such a unique object so early in the James Webb Space Telescope's observations. Most of the flares seen on the main body of the Sparkler galaxy are indeed massive and ancient stellar systems, providing a rare window into the cosmic past. The implications of this are huge. By analyzing the properties of these globular clusters, such as their age, composition, and the number of stars they contain, astronomers can gain invaluable insights into how stars and galaxies first formed. Before the James Webb Space Telescope, pinpointing the age of such early stellar populations in distant galaxies was nearly impossible. Now, we are finally able to peel back the layers of the universe's history. In an interview, Dr. Lamia Mola, an astronomer at the University of Toronto and co-author of the study, explained that their goal is nothing short of revolutionary. They want to date all cosmic objects, from stars to galaxies to globular clusters, and pinpoint when the very first stars ignited in the early universe. While astronomers estimate that the Milky Way contains about 150 globular clusters, their exact ages remain a mystery. However, the discovery of such ancient clusters in a distant galaxy like Sparkler could provide the clues necessary to solve this puzzle. Interestingly, dating younger clusters seen 9 billion years ago in the Sparkler galaxy is actually easier than dating the older clusters closer to home. As Dr. Mola put it, it's like estimating the age of a baby compared to an adult. You can more easily tell the difference between a 1-year-old and a 3-year-old than you can between a 50-year-old and a 55-year-old. To confirm the ages of these ancient globular clusters, astronomers used data from JWST's mid-infrared instrument, MIRI, which detected no signs of oxygen in these clusters. The absence of oxygen, a common element in younger clusters actively forming stars, suggests these are indeed ancient and no longer birthing new stars. But this wouldn't have been possible without some cosmic help. The James Webb Space Telescope's success in observing these distant objects was aided by both the Hubble Space Telescope and a phenomenon known as gravitational lensing. Thanks to Einstein's general theory of relativity, we know that massive objects can warp spacetime, bending light much like how a magnifying glass focuses sunlight. In this case, a foreground galaxy cluster known as SMACS 0723 acted as a gravitational lens, magnifying the sparkler galaxy and its surrounding clusters, making them visible to JWST. This lensing effect even caused some of the clusters to appear in multiple locations in the image. However, astronomers are still working to refine their models of how much this lensing is amplifying the galaxy and its clusters. The CONNECT's research team plans to develop more accurate magnification models, which will allow for even more precise age and distance measurements. What's next? The team is already planning to use JWST to investigate 5 additional giant galaxy clusters in hopes of discovering more systems like the sparkler galaxy. This opens up the exciting possibility of finding other ancient globular clusters, which could help unlock even more secrets about the early stages of cosmic evolution. Currently, there are 2 leading theories about the formation of globular clusters. One suggests they formed during the cosmic dawn, when the first stars and galaxies lit up the universe. The other posits that they were mostly formed during the cosmic noon, when star formation in galaxies reached its peak. The sparkler discovery could help settle this debate. But this isn't just about clusters. Data from JWST is shaking the very foundations of cosmology itself. Observations from Webb spectrometer and near-infrared camera have revealed that 4 of 6 key galaxies exhibit extreme redshifts, indicating they existed just 300 to 500 million years after the Big Bang, and yet, they show no signs of heavy elements like carbon. This is shocking, considering the universe is believed to be 13.8 billion years old. These findings suggest that galaxies were forming far earlier, and on much larger scales, than current models predict. The discovery has triggered debates across the scientific community, as these new observations challenge the prevailing Big Bang theory and its supporting cosmological inflation model. Even theoretical physicist Michio Kaku weighed in, saying that the detection of such massive, ancient galaxies so soon after the Big Bang is forcing scientists to question the very origins of the universe. After all, how could galaxies nearly 10 times the size of the Milky Way form in just 500 million years? To make matters more complex, NASA recently tweeted about another fledgling galaxy cluster discovered just 650 million years after the Big Bang. This young proto-cluster is expected to grow into a structure akin to the colossal Coma cluster, one of the largest galaxy clusters known. Researchers are now carefully measuring the velocities of these galaxies to confirm that they are gravitationally bound and will eventually merge to form a massive cluster. NASA scientists compared this process to tiny drops of water flowing into a powerful river, small beginnings with monumental outcomes. Clearly, our understanding of the early universe is at a crossroads. The Big Bang theory, while still a cornerstone of modern cosmology, might not explain everything. Could there be missing pieces? Alternative theories? Or is the Big Bang still valid, but triggered by an unknown phenomenon? One thing is certain, with every new observation, the James Webb Space Telescope is rewriting the story of the cosmos. As we wait for even more revelations from this groundbreaking observatory, we must remain open to the possibility that the universe's origins are far more complex than we ever imagined. What are your thoughts on these discoveries? Do you think we're on the brink of a scientific revolution? Let us know in the comments below. And as always, stay curious, and we'll see you in the next video.